In recent decades, we have entered the era of big data. In finance and all other sciences, analyzing data for prediction and making better decisions is crucial. The best and the most appropriate way to do this is by using programming language. Python is one of the most popular language for this purpose. In this video, we will present the basics of Python. There are different ways of using Python. You can install on your own computer, or you can use the cloud like Google Colab. So for this video, we will use Google Colab. So this is the screen. You can see that it is welcome to Colab. I'm going to open a new notebook. So let us start using this Python just as a calculator first. This is using this Jupyter notebook as a text. It is possible. And this one is a comment. So entering a number, for example, in a Jupyter notebook. For example, if you write 100, then this is just how we enter a number in Python. You can add also addition of number. Let's say this is 100 plus 100. Then I will hit Shift Enter, or you can click this, then the answer will be given here. But if you use the Shift Enter, right? If you use the Shift Enter, you will have a new cell. You will get the outputs as well as a new cell to write the next code. So subtraction, for example, 100 minus 100, Shift Enter, you'll get 0, and division, 100 divided by, this is a symbol for division, 100 divided by 100, you'll get 1, right? Also, you can apply other mathematical expression like 4 to the power of, this is to the power of, right? 4 to the power of 2, for example, is 60. Shift Enter, or in the same way you can calculate the square root of 2, 4 to the power of 0.5. So in Python, this double star stands for power, which is the square root of 4 is 2. Also, let us use for the calculation of some financial functions like the following. Open a text. We are going to use this formula, which is the calculation of forward value. That means if we put a present value here for n periods, right, you will get the forward value by this formula, 1 plus the interest rate r to the power of n times v, or the present value is given by this one. So PV is present value, FV is future value, discount rates, and n is the number of periods. For example, if you assume that we would receive 80 payment in 2 years, that the annual discount rate is 7%. So what is the equivalent value today? So to calculate this, using the formula 80 divided by, right, 80 divided by 1 plus, so the discount rate is 0.07, then to the power of 2, which is equal to this amount. So in short, we can use the Python also as a calculator. So when you talk about the precision, so the default precision is 60 digits, right, or 60 decimal places. For example, if I divide 1 by 3, you can see that 0.333, because it's never ending. So 0.3333. So if you count this one, is 60 decimal places, right? This is the default for Python, but you can use a rounding function in Python. Okay, round this 1/3 to 2 decimal places, 0.33. So to obtain more information, you can use the help function. Okay, it is good to know early about this function. For example, if you write this one, help, on the function round, you will get the following description, right? So these are the inputs that this function will take. Okay, so by default there is no number of digits is given. So the function round a number a given precision in decimal digits, right? In this way you can investigate all new things, right? So know more about. The next is we will discuss about the variables. What is variable? In most programming language, variables are values of given types stored in a fixed memory location, right? It is, for example, when we say PV is equal to 20, we are assigning the value 20 to a memory location which is given by the name PV, right? So we can change this value from 20 to other. We can make it 10 and so on. That is why we call it variable, right? So in this case, PV is integer. Of course, if you can write PV, you will get the value, or also you can say print PV. That means give us the value of PV. In case if you forget what is the type of this value PV, then you can access by typing what is the type of PV. You see PV is an integer. It is an integer. You can update the variable PV, right? For example, mathematically this one is not correct. PV is equal to PV plus. Okay, this is not correct, but in programming, when you say PV is equal to PV plus 10, what is the known value for this one? Okay, this is 20. So 20 plus 10, which is 30, will be assigned to the location PV, right? So the left side is just the name of the location, but the right side is the value of that location. So the value of this location will be updated to 30. So what is PV? PV is now becomes 30. Now calculating functions, there are other functions, built-in function in Python. For example, absolute value. If a is equal to -4, then you can calculate the absolute value of a. The absolute value of a is abs of a. Now you see this absolute value is a function that it returns what? The positive of this. So absolute value of a is equal to 4. Let us see more examples, like by taking a different variable. Here pi is equal to this one, t is equal to 252, s is this one and this one. Now what is absolute value of r? Obviously it is positive 999.99. This is what? A float. Okay, it is a floating number. Then you can change it to integer. The integer part of this, let's say an absolute value of r. First calculate the absolute value of r, which is positive, then you can take the integer. So you will get this one, and also you can round pi into 2 decimal places. You will get the result like this one. Also you can compute the minimum of this. There are very nice functions in Python, like calculating maximum. So maximum of pi, t, s, and r. You see, these are p, t, s, r. These are the numbers we are comparing. So what is the maximum of these 4? Obviously, you will get 252 is the maximum. In the same way, you can calculate the minimum of this pi, t, s, and r. The minimum will be negative 999.99. We will discuss later about modules more. We can import a module, or it is a collection of functions which is known as math, and we can obtain different function from this part, like for example, what is the square root of 81? For example, the square root of 81 is this one, and also we can calculate other values, like what is the exponent of, again, logarithm of 2. Remember, so because exponent and a logarithm is the inverse of each other, so you'll get what? The value equal to 2. And instead of using double multiplication sign, which is double star, we can also apply the power function for calculating, for example, 2 to the power of 3 or anything which is equal to 8. Very important thing in Python is to identify about the structure of data. So data types and their structure will be discussed here. Data type and structures. So the first thing, as we already said, it is about integer. Okay, we said about integer. For example, these are integers. Okay, s is equal to, when you say s is equal to 20, 20 is integer, and you can check the type of this of s is what? It's integer, and the next one is floats. Okay, the floats, for example, when f is equal to 0.25, this is a floating number, and if you request for the type of this data, you will get this information. And what is the type of 1/4? Obviously, again, it is a float. The other type of data is Boolean. So the Boolean type is either true or false. For example, 4 greater than 3 is obviously this true. You'll get this one. If you want to see what is the type of this 4 greater than 3, it is Boolean type. And 4 greater than or equal to 3 is also true. Or 4 is less than 3 is false. You can check also whether 4 is equal to 3 or not. So this, we have to use this equality, double equality sign, to check whether some quantity is equal to or not to other quantities. So you will get false. Or to check that whether a quantity is not equal to this quantity, so you will get true. You can combine booleans for forming logical operators, like this one, true and true. For example, what is true and true? True and true is obviously true, and true and false is false. Also, the logical operator false and false is also false. Also, you can check using or. True or true is true, and true or false is also, you know, that false or false is false. You know that here the word here and or called keywords in Python. Okay. Also, you can use the negation. not using not. Not is also another keyword in Python. Or negation of false is true, and negation of true is false. Other example here, 4 greater than 3 and 2 is greater than 3 is, as you can see, it is false because this one is true and this one is false. Then true and false is. Other example here, 4 equal to 3 is false, or 2 is not equal to 3 is true, therefore you'll get true. Also, what is the negation of 4 is not equal to 4 is true. Right, sorry, there must be space here, and this should not be repeated. We can convert Boolean into integer. For example, true is a Boolean, and you can convert to an integer. In this case, you will get 1 for true, and also false is associated to 0. False is associated to 0, and also you can change Boolean into Boolean data type, for example 0 into false, and the Boolean data type any number, actually, whether it is 1 or any number different from 0 will give you true. For example, 12.0 is a float, so this is true, which is different from 0. The next type of data is called string. So the data type string, here I will take example string 1. String 1, here string in Python. This is just example. Print string 1. So as you can see, you get this. There are different functions which can be operated on a string. For example, capitalizing the first word in the object or in the string. String 1 dots capitalize, you will get and is changed from small letter to capital letter. Also, you can find whether a word exists or not in the string. String 1 find using the find function, find Python. Okay, so what is the return? The return is 10. That means the word capital P started from the 10th character. Okay, and if there is no word that we are looking at, string find the word from the string 1. So if there is no, then you will get -1. Also, there is a function called replace for replacing characters in the string. String 1 replace, for example, let us replace the empty space here by this symbol. You see, then there are 2 space characters and they are replaced by this symbol. Another function can be operated on a string is called strip. Okay, stripping, that means deletion of certain character. Recall that this writing is a comment, so it is not a part of a code. Okay, this is a comment. We take a new thing here, example. So https www.python.org is just new string. So we want to delete some part of this string. So URL dot strip, okay, strip this one, HTTPS semicolon this one, okay, you will get only this one. So this is deleted, this part is deleted. And the other thing is we can access the characters inside the string by index of this type. For example, here string 1, the first character can be accessed in this way. The first character, small s, the first character access. Okay, what is the type of this data, by the way? The string 1, str, stands for string. Now let us take another string 2 example. So this is the second string. Now there is a function it is possible to concatenate. That means create a new string by combining the two strings. Okay, new string equal to string 1 plus string 2, means concatenation of the two. So what is a new string? You see, this is the new string. As you can see, this is the first string in Python, and there is no space. This is a string, so this one is due to the second string. This is due to the second string. So if we want to space here, we can modify string 2 like this one, or we can add here, okay, a space like this. Right? That means you can leave this one as it is, add a space character. Okay, that means this is just a concatenation of 3 strings: string 1, the character, and string 2. So you have space. And the other indexing is slicing, right? Slicing. Okay, we can access parts of the string using the index like this. For example, string 1 from 0 to 6. That means the first 6 characters of the string. Okay, this means the first 6 characters of the string 1. Also, you can count the number of characters in the string using the function length. String 1. There are 60 characters in string 1. You can count them here. So there are 16 characters here. Okay, the number of characters including the space. For instance, if you have this string 10 space 5 space 9. So what is the length of this string? S. Okay, let us count together. So 1 is the first one, 0 is the second, space is the third, 5 is the fourth, again empty space is the fifth, and 9 is the sixth. So the nature of a string is that it is an immutable object in Python, right? String is an immutable. That means the individual characters cannot be modified. Okay, we cannot modify with an assignment statement, and we cannot change the length. The length is fixed. So if we attempt to change this nature, we will get an error. For example, if we want to change s of 0, okay, s0 is the first character is 1 in the previous one. So if we try to say if s0 is equal to p, we'll get this error, right? The error says that string object does not support item assignment, right? Because here s0 is just 1, right? s0 is 1. So we cannot change that. Okay, the next one related to a string is formatting with f string. Again, we take example. Just this is example, units price given. Let's say a unit price is given, which is 29.99, and the quantity is given, which is 340. Then print. Okay, look, f, just we want to display subtotal. Okay, subtotal. You see, now we can insert the variable here, quantity multiplied by price. We get the following. You see, the subtotal is equal to this. Now to show commas in thousand, you see this is 10,000 something. It is better to get a comma in writing. So in that case, we can write as follows. Just we modify this part, copy this, and modify this. Small modification. Okay, so we add here comma. Interestingly, here we have a result here, 10,196.6. Also, if we want to get the pennies, right? Again, we can modify that in this way. Usually, these pennies should be displayed in 2 decimal places, right? So we get this one. So okay, this one. Yeah, so this is, you see. Also, we can format percentage. Okay, formatting percentage. For example, sales tax per rates. Sales tax rate is 0.065. 0.065. So I can print F sales tax rate. Again, you see we use this brace, curly brace, sales tax rate. So now there is no change, just we have the sales tax rate is equal to 0.65. If we want to write this one in percent format, right, we can modify this as follows. Again here, 0.2%. Okay. So this is a number of decimal places after the dot here, after the point. So if you make 1, you will get like this one. If it is, you use 9, for example, or 6, you will get like this, the number of decimal places after the point. So usually the appropriate one is this one. The next data type is tuples. So what are tuples? Tuples are sequence of arbitrary objects separated by commas and enclosed in parentheses, right? Tuples support the same operations as a string, and they are not mutable. Okay, they are immutable. We cannot change. Example, tuple 1. Example 1, tuple 1, a comma 3 comma 3.8. This is an example of tuple. Tuple 1. Print tuple 1. And what is the type of this data? It is tuple. So example 2. Example 2. Record 1 is equal to, say, John Smith 6 19 1479. This is a tuple. You see, the object in this tuple is string. This one is also string. Okay, this one is a tuple by itself. Okay, so we can unpack this tuple as individual object. Unpacking the tuple: last name, first name, birth dates, record 1. That means you see there are 1, 2, 3 objects. So we can unpack this object into the first one, last name, the second, first name, the third one is birth dates. So if you run this, for example, print first name. If you say print first name, this is Smith, right? Because it is in the second in this list, which stands for this. And birth dates. What is birth dates? It is a tuple by itself, right? So this is next. What is birth year? Okay, birth year is equal to birth dates of, okay, index 0, this is index 0, this is index 1, this is index 2. So this is a year. Then if you print this, you will get 1479. So again, let us apply the concatenation here. Name, record 1, record 1. Okay, concatenate. Let us take in space the character space, record 1 of 0. So what do you get? Then print the name. You get John Smith. So why we get error in the following? If I run record 1 of record 0 is, sorry, record of the first index is, try to change the first index or the first object by however. Okay, obviously tuple object does not support item assignment, or we cannot change the assignment. Okay, slicing and is also the same with string. So in Python also we have a very important data type called list. It is similar with tuple, but it is mutable. The element can be changed and can be modified. This is a way we create list. A list, for example, here, record 2. This is a list, so it is enclosed in square bracket JD 6 kid and 2. Here you can see it is the same with tuple. Okay, you have an object, maybe string, maybe integer, maybe float, or any other object. You can also have a tuple inside the objects of a list. Record 2, and what is the type of this record 2? It is a list. So in the similar way, when we say record 2 of 0, that means the first element or the first item in the list JD. When we say record 2 starting from 1, that means from the second item onwards, right? Starting from the first up to the end. The first means the second element, right? Because indexing starts from 0 in Python. It's not the same as MATLAB or other programming language, which starts from 1. We can measure or we can count the number of objects in the list also using the function length. Record 2. The number of object or element in record 2, in the list record 2. So unlike tuples and the string and so on, the list can be modified, right? For example, instead of record 2 at 0 JD, it was JD. Now I can change to Elhana. Now you see, modification is possible in the list. So now the new list will be, instead of the JD, here we have this one. Also we can append, that means, or we can add an element from the end. Okay, appending is also possible. Append, let's say 12.0 to the list. Example here. Record 2 dot append. Okay, it is a function. The list is as a module. You see, it has the functions and other methods. Okay, so 12.0. Now the new record will be, the new list will have additional number, which is 12.0 at the end. Also we can insert a new object. For instance, insert 10 in position 0. That means at the first from the first place. At the first place, record 2 dot insert at position 0 the value 10. So this is a new. Also we can extend. Okay, we can extend. That means we can add additional lists, like record 2 dot extend. Extend the record 2 by this one. This is a new list. Also we can extend record 2. It looks like this one. Also we can access parts of the list. For example, when you say record 2 from 2 to 4, that means starting from 0, the element at position 2 and the element at position 3, excluding the element at position 4. Right, so here, what is that? Look, this is 0, this is 1, this is 2. You see, it starts from 6 and 3. Does not include 4. So we can modify, okay, this part. Okay, modify selected element. Right, we can modify a selected element. Record 2 to 4. Okay, instead of this 6 and the kid, by the number, let's say by a new list, which is 1 1 1. So we modified our list. Record 2 now. Okay, instead of 6 and the kid, we have this new list is inserted. Of course, also we can remove any element from the list. Record 2, for example, remove this one, Elhana. Now if you see record 2, you will get the new modified. Very important thing we have to note is, if we want copy of a list or any object which can be mutable, we have to be careful. We want a new list which is a copy of record 2. Okay, this is just a reference or analyze to record 2. So anything we change on new record will be manifested on record 2. For example, if we make new record, okay, if we change the first element of new record here by 11, okay, that means change the list new record. This change will be reflected in the original record. Record 2, you see, 11. What was the first element of record 2? It was 10. Now it becomes 11. So we have to remember our intention, okay, when we copy. For example, if we want a new copy, right, totally different from record 2, we have to make as follows. We have to do it as follows. That means, let's say record 3 is equal to record. This is the list here. We have to use this semicolon. In this case, now this is an independent list from record 2. That means it is independent record 2. It is a copy, but it is independent of record 2. Which means if you change, okay, the first element of this new copied record by 13, for example, okay, the record 2 will not be affected, right? It will not be affected. So when we copy an immutable object, we have to take into consideration of this one. Now from list we can construct also a matrix. Okay, from list to matrices. For example, row 1 R1 is equal to just 1 2 3. This is a list 1. R2 is another list. 4 3 5 6. Let's say R3 is another list. 7 8 9. Then a new matrix M, which is equal to row R1 R2 R3. That means we create a list in a list. So our M is equal to this one. So remember that this M is also by itself a list, where the elements are also a list. For example, if we want to access, what is M0? That means the first entry of the list M0. Obviously, it is a list containing 1 to 3. And what is M of M of 0 of 0? So obviously it is 1, right? Or what is M of 1? M of 1 means the second entry in the list. Again, what is the third entry for this one? What is M of 1 of 2? That means first we take this, This is M1. Again, 2 means this one. Therefore, you have this quantity. The other data type is dictionaries. They are much like lists, except that the items are named instead of numbered, right? For example, here dictionary 1. Okay, it is written in this form. A is a key, and this is a value. B, the key, and value 2. C is a key, and this is a value. So we can access the value by calling the key here. So the value related to the key A is 1. So the indexing is not a number. Instead of number, it is a key. So this can handle a different type of data like this one. For example, dictionary 2. Let's say name, then value. That means you see the value is here. It is a string. Okay. An example here, age, which is a key term. The value is now in this case integer. So dictionary 2 of, let's say, age is obviously 3. Dictionaries can be modified. We can perform arithmetic operation with dictionary, like dictionary 2 age plus 3, for example, we'll get this one, and dictionary 2 age multiplied by 5, for example, just we'll get 15. And modifying dictionary is also possible. Dictionary 2 age is equal to dictionary 2 age plus 30. Okay, now dictionary 2 age will be modified by this one. The other thing is about distinction with if and for loop and so on. We will see on the next video. Thank you for watching.